Hello again, and on this video we're going to look at similar shapes and how to identify them. We're going to start with triangles, so we're going to look at similar triangles. So the real key point here is that any two triangles are similar if they have the same angles. They don't need to be the same size, but they do have to have the same angles. So the question is, are these two triangles similar? Well, we know that the angles inside a triangle add up to 180. We have two angles that look the same, so let's call this point A. Let's call this point A. Both of those are 50. We don't have this angle or this angle. Let's start with this one over here. So we know that if the sum of all the angles is 180, and we take away these two angles, we'll get the angle this side. 180 minus 75 is 105, minus 50 is 55 degrees. So we now know that this angle here is 55 degrees. Well, this angle here is actually 55 degrees. Now we've got two angles that are the same. Let's call this point B. Let's call this point B. Okay, so let's do this triangle here. 180 minus those two, which is 105, gives us 75. This angle 75 degrees. And let's call that point C. And also that's 75, that's point C. We can see that angle here is 50 degrees, as is this angle here. So those two are the same. We can see this angle here is 55 degrees, and this angle here is 55 degrees. So those two are the same. And finally, we can see that this one is 75 degrees and this one is 75 degrees, and they meet our criteria of having the same angles. Therefore, yes, these triangles are similar. So that in essence is what we're doing here. We are looking to make sure that each shape has the same angle. Now the sides won't be the same. This is the key point. So on this question, we are told that these triangles are similar, and we're asked to calculate length x. So we can see that angle BAC is 80 degrees, angle BAC is also 80 degrees. We've been told that they're similar, so angle CBA is 60, so angle CBA must be 60. We're told they're similar, so they have to be the same. And therefore, this one over here would be 30 degrees. We're not asked to do the angles here though, so we didn't need to do that. I was just showing you that. We're asked to find the length of x. If we are looking at side BC, so between the 60 and 30 angle, we're looking at side BC between the 60 and 30 angle. So we're looking at this side here. There's been an enlargement from the one to the other. But what is that enlargement? What is the scale factor? So what do we multiply 6 by to make it equal 10? So in order to turn 6 into 10, you are multiplying by 10 over 6. So 6 times 10 is 60, divided by 6 is 10. Therefore, we apply the same scale factor here to find x. We are multiplying by 10 over 6. So in this case, x is equal to 5 multiplied by 10 over 6, which is 50 over 6, which is 25 over 3. And that can just be shown as 8 and a third. The units are centimeters. Okay, on this question here, we're asked, are these triangles similar? So that means we've got to show that they're similar. How do we do that? We have no angles, so we don't know if they're similar. Well, if you go back to the last question, we said that shapes can be similar if one is an enlargement of the other. So in this case, we've just got to prove that the enlargement scale factors are the same for each pairing of sides. So let's look at our sides. Let's choose the first side, AB. There's AB. So what is the scale factor from there to there? Well, I think it's quite easy to say 3 times 4 is 12. So we know for sides AB, the scale factor is 4. So let's look at side BC. What is the scale factor there? So there's side BC, there's side BC. So now we've got 4. Well, 4 times 4 is indeed 16. So we've still got a scale factor of 4. Let's move on. Let's look at side AC. Let's see what that scale factor is. Here we are, side AC, there's side AC. So now we're going from here all the way to there, and it happens again to be a scale factor of 4. Okay, so because they all have the same scale factor, these shapes are similar. There we go. All sides have the same scale factor, therefore one is an enlargement of the other. These are similar triangles. Right, this question looks far more challenging. We've now got to prove that the triangle PQR, so here we go, PQR and RST are similar. We've got one line going all the way through. We've got another line going all the way through. So that means that this angle and this angle are the same because opposite angles are equal. Angle PRQ is equal to angle SRT. And that is because opposite angles are equal. Okay, so that's our first bit done. The next thing to identify is actually these two lines are parallel. So we've got a pair of parallel lines and we've got a line going through. If I just highlight this a little bit for you, you've got a line here which is parallel to this line here. And you've got a line cutting through both of them. Because of that, we know that angle RST is equal to angle PQR. That is because alternate angles are equal. Now, if you're not sure about the rules of parallel lines, that's something you need to go back and have a look at. But that is one of our parallel line rules. Quick recap. So if we have got a pair of parallel lines with a line going through them, let's say we've got this angle here, this angle here, so we have this condition here, they are alternate angles, and alternate angles are equal. Okay, let's move that forward. So we have now shown that two angles in both triangles are equal. So now we've got the green parallel lines. We've got a different transversal line cutting through it. And this time we are looking at this angle here and this angle here. That's exactly the same rule that we've just used, just a different way around. So now we can say angle QPR is equal to angle RTS. And again, that's alternate angles are equal. Now to say, are these two triangles similar? The answer is yes, because corresponding angles are equal. Therefore, triangles PQR and RST are similar, as corresponding angles are equal. Right, so this final question, or questions I should say. Notice now we've got triangles and, in this case, rectangles. Okay, we've been asked to find length x for each, but we are told that their shapes are similar. So this shape is similar to this shape, and this shape here is similar to this shape here. Now, if you can't see the two triangles, you're better off separating them and drawing them separately. So you can just recreate that, copy that below. When you do that, life becomes a little bit simpler. So now we can see corresponding length is 7 and it goes to 21. Well, 7 times 3 is 21. So our scale factor is equal to 3. So if we're going from the larger triangle to find the value of x to the smaller one, we are dividing by 3. So x is equal to 30 divided by 3. X is equal to 10 centimeters. So there you go, you found length x. Notice on this one on the right, the shapes are not in the same orientation. They don't need to be. So we can see that x is the longer side, therefore 9 is the longer side, 8 is the shorter side, and 4 is the shorter side. So what you will do here is you'll take the first one and you will work out its scale factor. In this case, we are doubling, we're timesing by 2. So the scale factor is equal to 2. So now we need to go from 9 to x. We're still timesing by 2. So x is equal to 9 multiplied by 2. X is equal to 18 centimeters. So scale factors are really important on this. So enlargement is something you need to think about. Is one shape an enlarged version of the other? And therefore, what is the scale factor? That always helps you through these questions. But the key message is the shapes to be similar, their corresponding angles have to be the same. They have to be similar in shape, but not necessarily exactly the same size. As always, if you've got something from this, please like and subscribe, and we'll see you in the next video.